Hello everyone and welcome to today's webinar, Optimal Pipetting Practices for Enhancing Workflows and Improving Traceability. I'm Cassie Soltman of LabRoots and I'll be your moderator for today's event. Today's educational web seminar is presented by LabRoots and brought to you by Sartorius. To learn more, visit www.sartorius.com. We encourage you to participate today by submitting any questions you may have during the presentation. To do so, simply type them into the Ask a Question box and click Submit. We'll answer as many questions as we have time for at the end of the presentation. Also, if you experience any technical issues, you can use this Q&A box and we will assist you directly. I'd like to now welcome our speaker, Joni Åke, Product Manager of Liquid Handling. Joni, you may now begin your presentation.
Thank you for dialing in. My name is Joni Åke and I'm a product manager at Sartorius Liquid Handling and I'm located in Helsinki, Finland. I'm just going to jump straight into it. We have a couple of topics. First, we're going to go through pipetting workflows and more specifically how to speed them up. Next, we'll talk about some practices that can help reduce the environmental impact of pipetting. And finally, we'll go over a couple of pain points in pipetting quality control. With Picus 2 pipette and how it can help you to speed up the pipetting workflows. Most laboratories that I've seen, they have maybe a couple of dozens of pipettes, but maybe just a handful of electronic pipettes. Two of the main reasons I've seen over the years why people switch to electronic pipettes are productivity and maybe ergonomic problems with the prolonged use of mechanical pipettes. Usually, electronic pipettes are used to increase the throughput of an experiment, especially when filling multitudes of 96 or 384 well plates. The second adaptation reason are the employees that might have injuries due to heavy pipetting, so they switch to electronic pipettes where it's much lighter for the thumbs specifically. There are other reasons why laboratories should consider changing the electronic pipettes. One of them being the reducing the variance between the users. As pipetting might be maybe the most common task in laboratory, it might not be the biggest one or most interesting one, but it's very common. Any time saved in pipetting can have a significant impact on the overall productivity. In some applications like cell culture, the less time you spend pipetting and handling the cells, the less time they need to be outside the incubator, leading to better cell health as well. So depending on the application as well, you might have some application benefits in addition to saving time. Electronic pipette can speed up repetitive or serial dispensing tasks and reduce the risk of manual error by using the multiple of pipetting modes that are found in the electronic pipettes. Perhaps the most iconic function of an electronic pipette is multi-dispensing. It can be one of the biggest time savers in labs, as if you're working with the microwell plates or large number of tubes. Multi-dispensing, it uses the reverse pipetting principle to aspirate multiple doses of the selected volume, which it repeatedly dispenses when you click the button. For most precise results in the mode, we have the prime excess, which is discarded before the first dose, and after the final dose, we have excess liquid. And those two together make sure that the first and the last aliquot are equal to the middle aliquots. Multi-dispensing, it requires some excess solution to be prepared, so be mindful, especially using multi-channel pipettes where you have 8 or 12 or number of channels aspirating at the same time. So consider that when preparing the solution. In this table, you'll see the pipetting mode combinations that are usable for Picus 2 pipettes. As you can see, there is a lot of options which you can utilize to save some time. By no means it means that you need to master all of them. I don't think anyone does that. But finding even one or two combinations that work for your application can help significantly to save some time. For example, for microwell plate work, multi-dispensing combined with the plate tracker function, it helps you to keep track of your progress where you're in the plate. Or for zero dilution, you could utilize automated mixing combined with the normal standard pipetting, so you don't have to mix up with the settings or press the plunger too many times. Another reason I briefly mentioned in the beginning why you might consider switching to electronic pipettes is because the pipetting accuracy greatly depends on the user experience. And here we show the importance of the hands-on experience, especially as you move to the lower volumes. The smaller the volume, the more challenging it is to pipette. In the graphs here, we compare results from three different user groups: the inexperienced office workers that were briefly introduced to the pipetting, moderately experienced professionals with hands-on experience working in a lab, and then finally, the third expert group is the people from accredited calibration laboratory who definitely know how to use pipette. And what you see here is regardless of the expert level, an electronic pipette helps eliminate some of the user-based variance that you'll see in a lab. So that's one of the big reasons why some labs consider switching to electronic pipettes, especially for those applications where it makes big difference. The next logical step after utilizing the electronic pipettes is to utilize smart features and connectivity in electronic devices. With Picus 2 and Sartorius Pipetting app, it can help you to speed up the more complex preparation workflows. Let's look into how this actually works. So this is just one workflow example. Here on the left-hand side, you'll see the template creation. It's a pretty small picture, sorry about that, but it's a web-based application that you use with your laptop or in the office. You create the templates for the workflows. And on the right-hand side, the idea is that you are in a lab, you have a mobile device like phone or tablet where you execute the workflow. In the lab, how it works, you log into the app, you choose the template that you want to use. The app checks the pipettes that you have available. It checks if the calibration is due. It checks if there is sufficient battery charge level. And it also chooses the best pipettes for the job. Then, when executing, you have step-by-step instructions at the correct time to remind the operator what needs to be done. This can be very useful if you have a long preparation protocol. I know that they can be many hours in some of the cases. And then also when you have less experienced users. So it helps them to learn new protocols. And by less experience, I don't mean that they don't know what they're doing. I mean that they haven't done that protocol maybe 1 or 2 times only. So especially in those cases, it helps them to be comfortable with the protocol they are doing. It helps reduce the user stress as well. And then as said, the app also chooses the best pipette available for each task. Then it connects to the pipette and sends correct pipetting parameters. This helps the user to be faster, as the setup steps are not needed during the execution. So all the volumes, speeds, which mode should be utilized, everything is sent automatically to best fitting pipette that you have available. Not only that, but this also helps standardize pipetting between the operators and maybe between different weeks that you are working in a lab. Or everything is set the same way. All the speeds, all the volumes, all the modes is set exactly the same way as defined in a template that you've created. This minimizes the variation that might be coming from pipetting practices. And also it helps to minimize the variance between the operators, as all the operators are using the same settings every time. And then, as with the most things in life, there is always something happening. With the app, you can record all deviations that might happen. So if you, for example, pipette twice in one well, then at the time of execution, you can already note down what happened. So you don't have to remember afterwards, which well was it? Was it B4 or B6? Then you can use the note functions to record plate numbers, or maybe you want to have a record of what batch or what consumables were used or even like the consumable number or the batch of the consumable. All this information per se might not be that interesting. But down the line, if you notice that in the final analysis you have something a bit odd, something you didn't expect to see, then you will have the log file available for you to double check what happened during the preparation steps. And finally, after all the steps has been taken, they are recorded automatically. And all the notes you created during the execution, they have an assignment to the task that the note was taken during. Of course, after the protocol is complete, you can always add notes, but the notes added during the protocol, they are assigned to a certain step. So you know if you add a note that, hey, I missed a well A4, for example, you know at what stage during the workflow you didn't miss that. All the reports, they are saved in the database for later access, or if you prefer, you can have a PDF copy saved wherever you need. So for example, if you have a system in your lab already in use, you can save those notes in the same system as a PDF, which is pretty handy. And here, these are the screenshots how the app actually looks like. Let's start from the left. First screen is the parameter setting. So we do have those templates that we make in the office, perhaps or ideally with a larger screen. And for the templates, it's possible to assign certain parameters. Like we know that not every time you have exactly the same number of samples. So a number of samples might be a parameter that impacts how the workflow is run. So in the morning, we had 5 samples, and in the afternoon, we had 12. So the afternoon protocol is going to be much longer. There's more repetition. Next, we have an aspiration step with the multi-channel pipette chosen for the task because we are transferring to the plate diluent from diluent reservoir to dilution plate. So multi-channel pipette makes most sense because you need to do multiple pipettings here. And then the next one, we have a aspiration step with a single channel pipette because we are aspirating from a compound tube where you can't fit a multi-channel pipette, so a single channel pipette makes the absolute sense here. And finally, on the most right-hand side picture, we have a dilution step. So we have a serial dilution ongoing here on the 96 volt plate, and there is a transfer step from 4 to 5 with the 8-channel pipette, and then automatic mixing is followed by this. So you transfer the liquids, and then you mix, and then you're ready for the next transfer. So performing dilution series is definitely less painful with the help of the app. Using the workflow method for pipetting, it saves time on setting up. Of course, the initial setup where you create the template might take a little bit more work, but if this is something you do every day, every week, every month, it definitely saves you some time in the long run. It saves time on setting up the pipettes, and it always utilizes the best pipetting options for different steps. In addition to that, the users get the on-time instructions about the step that they're doing at the moment, meaning the protocol is executed the same way every time. And in the end, there is an automatically generated report of which you see an example here. And all the comments, all the inputs that you put in are also included in the report. So you can save this as a backup information wherever needed. So this means that whenever there is unexpected results in the end, you can always return to the sample prep steps that you take for that protocol. All right, now there are different topics. So let's look at a couple of things that can help to reduce the pipetting environmental impact, an important topic for all of us, I'm sure. Pipettes are typically used for a long time, even more than 10 years, or even more than that, I've seen. The manufacturing and logistical choices don't have such a large impact overall. though every bit counts, and reducing, for example, the packaging size can reduce the transportation impact quite significantly. Just make sure that the pipettes you've chosen, they have spare parts available, as well as the service and calibration. So they will function many years to come. However, there are a couple of things, I would say two major contributors on how pipetting practices can have an impact towards more sustainable lab. First one is think ahead. So pipetting in a smart way that utilizes the consumables that are typically plastic and reagents in a smart manner. So plan ahead and, for example, do multi-dispensing and utilize the one consumable to fill the plate if possible. And then the second one is kind of obvious actually. Pipette the assays correctly the first time. So then you don't have to redo experiments. That's not only saving on the consumables and reagents and samples, but it's definitely saving a lot of time. And having a pipette tip combination that works perfectly definitely helps to perform the prep steps right the first time. Pipetting definitely is a repetitive task, so planning the work in a way that you can utilize the same consumables the maximum time. So use helpful features like multi-dispensing, pipetting all diluents in a sequence, so you can use one tip or one set of tips if you're using multi-channel pipette. Planning in advance definitely can help here. Maybe you'll find a way to minimize time spent on pipetting at the same time as you're reducing the number of consumables used. Then to the pipette tips, which definitely is a very common consumable in a lab, and they can have substantial impact on the lab's environmental footprint. For a tip selection, I would consider a couple of things. The direct environmental impact, the manufacturing, transportation, and disposal, and then the indirect environmental impact, which might not be that obvious when choosing the tip, but definitely choosing the tip in a way that it doesn't impact the pipetting results and potential rework, kind of similar as with the pipette selection earlier. Choosing the tip that perfectly fits the pipettes can reduce the variance coming from the system. And it's important to remember pipette and tip, they work as a system. There is no systematic or random error limits for pipettes. It's always for the pipette and tip system. And then on the direct impact side, I would definitely focus on reducing the plastic where we can. For example, using the refill option tips when possible, because they are typically packed in a cardboard. This helps on the reducing the manufacturing impact as well as disposal impact, because there's less plastic overall. And refill tips, they are typically also packed more tightly, meaning that there are more tips in the same space, which means that the transportation is more efficient as well. Here we have an Sartorius OptiFit tips used with Sartorius Picus pipette compared with 3 other tips. And here you see why I said that the pipette and tip are always combinations. So just by changing a tip type, you can see quite a big impact on the results you get. So this is regarding the non-direct or one of those things that might not be so clear. And just by changing the tip type, exactly the same pipette works exactly as planned, but you'll see a difference in results. You can adjust the pipette, and this is important as well. You need to adjust and recalibrate the pipette if you switch the tip type. So for the black graph or the black bars and the red bars, you could adjust the pipette to work with those ones, but the teal ones or blue ones, that might be a challenging to adjust to work well, because you have results that are below and results that are above. So it might be a bit challenge to adjust that for to work with the pipette. And with the new ISO 8655 standard series update, the responsibility of providing the claim and proof of pipette tip compatibility is with the tip manufacturer. So if you're wondering if this combination is going to work, I would first turn to the tip manufacturer to ask for the compatibility claim and the proof for that claim. Okay, now let's jump into the easier to manage or easier to find out impacts, or especially on the tip side, so amount of plastic. In this slide, you'll see the comparison of amount of plastic used in a 300 microliter tips in different packaging options. So the tips themselves, they are exactly the same and there is same amount of tips. The only difference is here how they are packed. Of course, there are some differences between the options, like usability and purity, for example. So single tray tips are the most convenient to use. You just need to open the wrap and use it. And you can have those as a pre-sterile option as well. Then on the other side, the bulk option or the refill option, they require a little bit more work, but they can save quite nice amount of plastic used for manufacturing, which helps on the disposal side of things as well, obviously. But some of these might not be available exactly as the variant as you need. So the key message here is consider if for this application you could utilize like refill option, refill tower, for example, which is available as a non-sterile option. But definitely if you need a sterile option, then the single rack or refill sterile option is the only way to go. And here are the same tips, and we're just calculated the savings. So with the sterile refill system, which is the bottom left-hand corner, you save 30% of plastic weight compared to single racks. And with the non-sterile refill tower system, you save 50% reduction in the plastic weight. And the best option is in terms of saving plastic use, is the bulk option. But obviously that's not as handy to use as those refill systems or single rack systems. So you have to choose which compromise or which option weighs more in your use case. And there is a huge amount of tip options available in the market, and it might be very challenging to compare them, especially when it comes to the environmental impact. So one of the options is the ACT label by MicroinLab. There is a link in the screen as well if you wanna see. MicroinLab is a non-profit organization. They provide the ACT label as a service to companies, which makes comparing different laboratory consumables or instruments a little bit easier. So it's kind of like how nutrition labels provide information on the food products. The ACT label offers insights into the sustainability performance of laboratory products and consumables. It categorizes and rates product based on various sustainability related factors, allowing users to quickly assess and compare the environmental impact of the product that they are planning to purchase or are already using. Sartorius has this available for the refill systems, so definitely I would recommend to check it out if this is something that interests you. Okay, final topic for today is pipette quality control. Here we'll go through some of the things to consider with pipette maintenance and calibration. Let's start with the maybe why slide. So pipettes are precision instruments which require regular care. And the only way to tell if pipette is working like it should is to calibrate them. And according to the standard ISO 8655, it's up to the user to establish this testing routine for pipettes. Definitely, I would recommend as a best practice here to approach the calibration and maintenance requirements or setup from the risk point of view. The more critical the application, the higher the frequency as a rule of thumb. But from the standard, it comes to that you should perform pipette testing minimally once a year, so every 12 months. That's like the minimum requirement from the standard. To be able to validate if a pipette is working when you send it to service, ask for a as found calibration. This means that the testing lab will do calibration for the pipette with no adjustment, no maintenance, not opening the pipette, and you'll find if the pipette was working when you send it to service. Like as typically during the service and calibration, the pipette is opened, they are inspecting parts, they are cleaning it, they're recreasing it and putting it together. So if you only rely after maintenance calibration, you have no idea if the pipette was working when you send it to the calibration or a maintenance and calibration or not. So having the pipette tested before maintaining, then having maintenance, and then having calibration as left or when it's ready to go back to the user, there you have a pretty good understanding if the pipette was working before and after the maintenance. And when pipette system including the tip functions properly, you can expect good results. And here again, I would like to highlight this, that the pipette definitely works as a system. So for a pipette, there is no systematic or random error limits. It's always for the system. Pipette plus tip. So now let's jump into the interval a little bit. So here we have a imaginary graph of one pipette results over the certain period of time. So depending on the interval you have defined for the calibration, it might be the 12 months. It's very common what I've heard from Pipette users. But there is then, if you have the 12-month calibration interval, there might be 12-month period of time that you have no idea how the pipette is performing. So a recommendation here is to have an in-lab, in-use testing routine, which is complementing the pipette calibration. By no means this is replacing the calibration, but it's a complementary act, just an extra assurance for you that you know that your pipette is working like it should when it's in the lab. So the setup can be quite simple, something like analytical balance, distilled water, etc. And then some sort of a tool, which can be a simple Excel file to collect the results and to calculate the systematic and random errors. So the aim here is to have a verification that the pipette is within the set limits, and then having a data to prove that if needed. This can be very useful. So let's say that you've performed an assay in assays between the calibration points, but then you utilize the as found calibration here in the second point, so middle maintenance and adjustment point. But if the results are out of the tolerance limits, then what should you do? What happens? What should you do with the work that you've done with the pipette previously? The first initial calibration, that was perfectly spot on. But the first as found calibration was a fail. So were the results in between those 2 points okay or not okay? There is no way of knowing that at which point the pipette drifted outside the calibration, unless there is something obvious that the pipe was dropped or some physical damage, then it might be obvious. But if it was drifting, you have no data points in between those 12-month period of time, how to evaluate which of the work done with the pipette is okay and what is not. So that's why having those routine checks, like every week, every month, even every day I've seen in some critical applications, or before starting something very important. But having those data points can help find the time when you need to either check the pipette, or if you return to that data afterwards, you can find the point where the pipette started drifting. Then, why you might see such drifting on a pipette plus tip combination? Well, the obvious ones are the physical damage, like dropping the pipette on the floor, or physical mishandling, like if you twist the pipettes when attaching tip, that might cause some damage, or if you bang the tips on to the pipette, that might cause some damage. Then there are several challenging liquids that can destroy the pipette lower parts. Some of the aggressive chemicals can attack the plastics used or the seal, rubber seal used, or then there is also grease at the seal point that helps to seal the system. Some chemicals can attack that grease as well. Over time, it might deteriorate the grease and loosen the seal, so that might impact or cause some drifting or leakage even. Then storing the pipettes incorrectly. Here, an extreme case could be that you store them on a table and some liquids get into the pipette by accident, or some dirt. But even just storing the pipettes for a long period of time on a sideways can cause the set grease to go on the other side of the pipette. But typically that can be just use the pipette a couple of minutes, check the performance, and you should be good to go. So the grease will spread out once you start using the pipettes. So if you have a long-term storage for pipettes, it might be a good idea just to double check the functions before taking them back into use. And then by just using the pipettes, you will eventually see some change in the performance. Pipettes have moving parts, and moving parts are always subject to wear and tear. So then the calibration interval. How often then you should calibrate the pipettes? So the ultimate responsibility is within the users. So they are responsible for setting the calibration routine. But as said, minimally it should be every 12 months. And this is coming from the ISO 8655 standard. Then what should I consider when deciding how often to calibrate pipettes? Well, first thing I would consider is what kind of work do, how robust is the application, what kind of uncertainty I can accept from the pipetting. Then how often the pipettes are used. If they're used 8 hours a day, they are definitely going to wear out sooner than if they're used once a week. And then some of the typical calibration intervals that have been chosen is like 3 or 4 months, 6 months, and 12 months. Those are very commonly being used. Then choosing the service vendor, it can be quite challenging. There is a lot of vendors out there that offer pipette maintenance and calibration. Couple of things I would personally consider when choosing such vendor is I would look for ISO 17025 accreditation. It provides a proof that there is traceability to national and international standards. Then I would check if they have training for maintenance and calibration by the pipette manufacturer that I have in use. So not all the pipettes are similar and not all of them are serviced similarly. Then I would also ask if they have access to original spare parts and if they use original spare parts. And if they have state-of-the-art equipment, like if they're doing gravimetrical calibration, do they use modern balances? Do they have modern calibration environments? Pipettes are calibrated in very special room, which is the air temperature is and air humidity is controlled and measured. And then obviously tip is to ask from colleagues, ask from people who you know, does the service provider have a good reputation? Then finally, we have a safe liquid handling range, which is a completely new thing to the ISO 8655 standard. It's part of the part 10 of the standard series. It contains user guidance and requirements for competence, training, and pipette suitability for the application. And one of the things the part 10 talks about is safe liquid handling range. And aim here is to define minimum usable volume for adjustable pipettes. And definitely based on the application needs. Simply put, when a relative uncertainty of delivered volume of the pipette exceeds the process or application tolerance, it should be the point of minimum usable volume. So when they meet. And the reason why you should determine this for your pipette is quite simply the fact that adjustable pipettes are most accurate at nominal volume. So nominal means maximum volume. The lower the volume, the more uncertainty you have that if the volume delivered is what you said it to be. And this can also be seen if you check pretty much any manufacturer the tolerance sheet or the maximum error sheets that you find for pipettes and tips. You'll see that at the maximum or nominal volume, you have least amount of error accepted for the pipette. And if you go scroll or change the volume to the lowest point, you have the maximum errors allowed for the pipette. The liquid handling process tolerance here in the graph, it's including the uncertainty coming from the pipette user, the liquid that you're pipetting, and the environment as well. So it might be a little bit challenging to determine this, but check if your service provider could help and provide you some of the examples on how to approach this.
Wonderful. Thank you for your informative presentation. We will now start the live Q&A portion of the webinar. If you have a question you'd like to ask, please do so now. Just click on the Ask a Question box located in the lower left corner of your screen. We'll answer as many of your questions as we have time for. Let's go ahead and get started here. Our first question for you is, are electronic pipettes more ergonomic compared to manual pipettes?
Yeah, definitely they can be, especially when you pipette a lot, and an electronic pipette can take a lot of the stress away from the user. A good manual pipette is an excellent starting point compared to those old ones that you've seen most likely in a lab, but an electronic pipette with all electronic operations definitely will help.
Excellent, thank you. All right, our next question here asks, what kind of training or support is available for new users?
We offer instructional videos. You can find them on Sartorius YouTube channel or via the Sartorius Pipetting app, and also on the sartorius.com you'll find instructional videos, instruction manuals, best pipetting practice guides, application notes, practical guides, etc. And then we have a user training concept pipetting academy. You can reserve an academy for your group, team, lab, whatever. So the easiest way to find out more is to check on the website or get in direct with Sartorius representative.
Great, thank you. All right, moving along here. This next question asks, what type of applications or experiments benefit the most from using electronic pipettes?
I would say the ones that have more pipetting definitely benefit the most. Simple reason is that with an electronic pipette, over the time you'll get better results as the human factor is significantly smaller with an electronic pipette. So whenever you need to repeat a lot of pipetting, or you need to repeat an assay multiple times, you're trying different concentrations, etc., then an electronic pipette definitely is a way to go.
Excellent, thank you. All right, we have time for a couple more questions here, so I'll ask our next one. This next question asks, how durable are electronic pipettes compared to manual ones, and how are they maintained?
Okay, the basic maintenance is exactly the same. So you have the lower end, you have the pistons, seals, and cylinders. They need to be kept clean, and they need to have re-lubricated every now and then, depending on how much use you have. So it's exactly the same. Obviously, with an electronic pipette, you have electronic components like battery that will need a replacement every now and then, but it's not that much different. And the durability-wise, I'd say they're on the same level as mechanical pipettes in a sense that all of them are measurement devices. So if you happen to drop one off the table, I would definitely go for a calibration or pipette testing before I would utilize any pipette, regardless if it's an electronic or mechanical one.
All right, wonderful. Our next question that we have here asks, how does storing the pipettes horizontally affect the accuracy?
Yeah, that's a very good one. A short storage horizontally will not have any impact, although it's more likely that you will have any liquid or dirt getting into the pipette lower end if you store it on the table. I think that's one of the main reasons that companies don't recommend storing them horizontally, because then it usually is laying on the surface and it's easy for dirt or liquid to get into the pipette, which is obviously a bad thing. On a long-term storage, like the pipettes are shipped on the boxes that are typically horizontally, it is possible that the grease that is on the piston seal area is gonna go down onto the lowest point. But that's typically not a big problem, because when you move the piston up and down a couple of times, then it usually spreads out automatically.
All right, great, thank you. Looks like we have one more question here. This next question asks, can electronic pipettes handle different types of liquids, e.g. viscous or volatile?
Yeah, absolutely. Most electronic pipettes have profiles that you can utilize. For example, our Picus 2, you can store up to 5 user-made profiles that are adjusted for your specific liquids. For example, I would definitely have a profile for high viscous liquids or volatile liquids, because they need to be handled differently. In addition, an electronic pipette is excellent for handling those challenging liquids, because you can adjust the speed settings and you can utilize the modes like multi-dispensing that it has. Both of those, especially the speed setting, will increase the accuracy and precision.
Wonderful. Thank you. I want to thank you, Joni, for your time today and your important research. We would also like to thank LabRoots and our sponsor, Sartorius, for underwriting today's educational webcast. Before we go, I'd like to thank the audience for joining us today and for their interesting questions. Questions we did not have time for today and those submitted during the on-demand period will be addressed by the speaker via the contact information you provided at the time of registration. So please continue submitting your questions as they will be answered. This webcast can be viewed on demand. LabRoots will alert you via email when it's available for replay. We encourage you to share that email with your colleagues who may have missed today's live event. Until next time, take care, everyone. Goodbye.